Hello, my name is Milton Lord. My amateur radio call sign is N4DA. Before we move directly into our topic, just a word about these videos and others in our series. I've designed these tapes to be used by any amateur radio operator, regardless of his or her technical ability. These tapes can be used to maintain and adjust your transceiver without the use of any test equipment or manuals whatsoever. Now, on to our topic. This is our topic transceiver, the Kenwood TS-430S. We're going to be discussing how to cure some problems on the 430, including low-pass filter relay oxidation, low power output problems on the power amplifier, how to replace the lithium battery, how to replace the pilot lamp behind the S-meter, how to calibrate the digital frequency readout, and how to modify the transceiver to transmit on any HF frequency. Before we go into detailed service work on the 430, let's take just a minute to talk about some of the tools that we'll be using. We'll be needing a Phillips head screwdriver, a small pair of needle nose pliers, a small flat blade screwdriver, a pair of diagonal cutters, solder wick for removing soldered components from PC boards, electronic solder, rosin core, a small pencil-type soldering iron, a very inexpensive analog volt-ohm meter, and last, we'll need a resistor between 10 and 20 ohms that's capable of dissipating at least 2 watts. The first problem that we'll be talking about on the 430S is a problem involving the relays on the low-pass filter unit, which is located in the rear of the transceiver near the final unit. This problem manifests itself as a condition of low receiver sensitivity on certain bands. The way that you'll notice this symptom is that when you're receiving and you're stepping through the different bands, you may find that you have a particular area or band where the receiver sensitivity seems to drop very, very low. This is particularly noticeable when changing from 3.9 to 4 megahertz. Usually if you have the problem, this will be one segment where it will show up. Now in this particular unit, it's not displaying this problem because the relays are fine. So if you notice that switching between 3.9 and 4, for instance, at 3.998 you can hear good background noise with an antenna connected. When you go above 4, you will notice that noise drops off perceptibly. The same thing may be true when you're stepping through different bands. You may, for instance, hit 21 megahertz, 15 meter band. You'll notice that the receiver sensitivity has really dropped off. Normally what's causing this is that the filter relays become oxidized due to lack of use on particular band segments or because they're not being used for a long period of time when the radio is in storage. And sometimes it can also happen if the radio is used in an environment that's exposed to cigarette smoke or any other type of a substance that's airborne that can get on the relay contacts. Now this problem is easily cured by using a power supply and a resistor to pass a current through the relays to clean the contacts. And this can be done without even removing any of the case screws whatsoever. It's done strictly with a power supply and resistor. And I'll show you in detail in just a moment how to accomplish that. We're going to be using that resistor that we talked about when we were showing the tools that we're going to be using on the 430 to clean the relays on the low-pass filter unit. And this is the way this is accomplished. We take the radio and we take the antenna connector, which we have an antenna installed presently, and we're going to take a small alligator clip and insert it into the center pin of the antenna connector. We've pulled back just a little bit to give a wider shot so we can see a little bit more of what we're doing. As I said, we put this in the antenna connector. we'll take the other end and we'll attach it to one end of the resistor. The resistor we're using here is a 20 ohm 25 watt resistor. You can use anything between 10 and 20 ohms. It doesn't have to be 25 watts. A 5 watt resistor will work just fine. Perhaps even a 2. It is going to get awfully warm with the 2 watt resistor. What we're going to do is take a power supply. Now we can use our existing power supply that we're using to power the radio to do this. What we'll have to do is attach a set of alligator clips or leads to the 12 volts. And that is in addition to the power supply leads that are already going to the unit that is being used to power it. But we can use the same power supply to provide the power to the radio and to also do the cleaning action on the relays. We'll take the negative from the power supply, from the same power supply or another power supply, and attach it to ground. We take the resistor that's going to the center pin of the antenna connector and attach our positive lead here. Now we're out of the camera here. Let's get a little bit closer. We attach our positive lead to the other end of that resistor. And when we do this, if we're using the same power supply, we're going to turn the power supply off so that we don't start drawing current immediately through the relays. All right, we'll turn the radio back around so that we can see what we're doing. All right, now we've got the power supply off. In this case, we're going to be using the same power supply that we're using to power the radio. Again, we have taken a 20 ohm resistor, positive lead to one side. The other side of the resistor goes to the center pin of the antenna connector, and the negative of the power supply goes to the case ground of the unit. Turn the power supply on and immediately push the up button on the radio. Put it in the 1 megahertz step position, which is right here, so that it is stepping 1 megahertz at a time. We want to hold the up button down for approximately 2 minutes and let it step through the relays. What this is doing is passing approximately 500 milliamps of current through each of the relays on the low-pass filter board. This will clean any oxidation that is built up on the relay pins. Now, the problem that I've described to you before is symptomatic, or the symptom of the problem is that we have low receiver sensitivity on certain bands. Now, that doesn't mean that we have any transmitter problems. This won't cause transmitter problems. It'll only cause intermittent receiver problems. And the digital display will never go blank with this kind of a problem. If we had a blank digital display on certain bands, that would indicate another problem dealing with PLL unlock. And this is not associated with that. This is only associated with low receiver sensitivity on certain bands. And the cure that we're curing here, the cure for the problem, is only going to take care of that problem and no others. So we've held this down for approximately 2 minutes. And then we can pull our antenna connector out. And you can actually feel the resistor when you're through it. It'll be quite warm because of the current that's passed through it. That's why we want to use the highest wattage resistor as possible, because this does get quite warm and we need to dissipate that current. So we don't want to use anything like a 1 watt or a half a watt resistor. We must have at least 2 to 5 watt resistor. Now, when you've done this, what you can do is put your antenna back in the back of the unit. Turn up the volume. And you can step through the bands. And that should have cleared the problem where when we went between certain band segments, the receiver would certainly go very, very quiet or low sensitivity. And as I said before, this will be particularly noticeable if you're having the problem normally between 3.9 and 4 megahertz. You could actually hear, if you turn the volume down, you can actually hear the relay in the rear of the unit changing in and out. That's the cure for low-pass filter relay oxidation. Now let's take a look at a common problem on the 430. The symptom of this is intermittent transmit power or very low transmit power. What we notice when we transmit on the 430 when we have this problem is that when we're in any mode, single sideband, upper sideband, FM, it doesn't matter, normally the radio will put out approximately 100 watts. And when we have this power, or this problem, the power will be down to somewhere between 10 and 50 watts. And it may operate normally at times, and at other times the power may drop while we're talking or using CW. And there doesn't seem to be any rhyme or reason sometimes as to why this is happening, and when you're operating it you can't understand. You think sometimes it's because it's getting hot, or maybe it's because it's cold and you've got an intermittent contact somewhere, and you're right, that is what's happening. But the problem is easily fixed. There's two things that cause it. One, we've got an intermittent connection on the IF board, or we have an intermittent connection on the power amplifier. And we're going to go into detail and talk about how to fix those problems. But first, let's take a look at the symptom so that you'll know exactly what we're talking about. And when you see this condition on your radio, you'll understand that this is what's causing the problem. All right. As I said before, we will be transmitting, and we'll notice the power on the watt meter. Let's take a look at our watt meter. We're now looking at the watt meter, and we're transmitting with the 430 in the CW mode with the carrier control turned maximum clockwise. Now we see we're generating approximately 90 watts. The top 10 that you see on the scale, the top 10, which is right here, that is 100 watts with a 250 watt slug in this meter. Now this radio that I'm using actually has the problem that I'm describing. At the present time it's working, and this is one of the characteristics of this problem, is that many times the radio will appear to function normally, and when you try to use it for sustained periods of time, the power level will suddenly drop. And just a few minutes ago I was testing this radio, and that's what was happening. But at the present time it is working, so I'm going to simulate the condition by turning the power level of the carrier control lower on the front. This is what you'll see when you have this problem. You'll notice your power level is up there, and then all of a sudden we're down here like this. And you can sometimes key the radio on and off sometimes, and actually sometimes you can tap the top of it with it in the transmit condition, and suddenly it'll pop back up. That indicates that we've got a faulty connection somewhere. Now my experience has shown me that 99% of the time this will be occurring in two areas of the radio. Let's talk about where those areas are and what do we do to solve the problem. The first thing we have to do is gain access to the inside of the radio, so we're going to have to remove the top and bottom covers. First, we want to turn the power off and remove the power cord from the rear of the radio, and remove 4 screws on the top, a screw location here, one in the middle, and one in this location here. The same is done on the other side, same screw locations. And on the rear of the unit, we remove a screw location here, here, and in the rear of the unit, one on either side. And that will allow us to have access to the bottom and top of the inside of the 430. All right, we've gone ahead and removed the bottom cover already from the 430. We've removed the screws from the top of the front panel, and we'll remove the top panel, and remove that next. And we pull our speaker lead loose. Before we lay this aside, we want to make sure we've taken this loose, or else when we quickly swing it off, we might break that lead. There's really only one blank plug connection here, so when we get ready to put the cover back on and reconnect the speaker, it's easy to see there's really only one location in which it would go. We're going to be hooking back up our power connector to the rear of the unit, and then we'll be powering the unit on. And we're basically going to be doing the same thing that we were doing before. We're going to be watching the watt meter and looking at the power to see if we can make it drop, or if it's already down, make it come back up. We're now looking directly at the top PC board in the 430. This is what is directly under the top cover. It's easy to see that there's a lot of wiring here, and there's a lot of plugs, and this is a densely packed PC board. We've got a lot of areas on this board where we could develop some bad connections because of these push-on connectors, and this is one area of the board that can cause our problems with the intermittent power or low power because of this. So the way we check to see if the problem may be here, we transmit in the CW mode with the carrier control fully clockwise. That's the control which is also the concentric with the mic gain control. And we either look at the IC meter on the front of the unit or an external watt meter while we're doing this. And what we're going to be doing is, while we're looking at the watt meter, we're just going to take our hand and we're just going to push on this board to see if the power fluctuates. We're now looking at the watt meter. We're transmitting in CW at full power, and what I'm doing is just taking my hand and I'm applying pressure to the IF board, top board that we were just looking at in the 430, and you can see there's no fluctuation in power, so there doesn't appear to be a problem here. One other thing you can do is you can take your carrier control and reduce the power to somewhere between 75 and 100 watts. That 5 is 50 watts. Between 75 and 50, I should say. What that's doing is taking the radio out of the ALC range, so that any small fluctuation in drive power that's delivered from the IF board will result in a pretty big change of power output. Now you can see there's a slight change there when I push on this board, but that is not a big enough change to be the problem that we're seeing with the power output being very, very low. That is normal for that to do that. Now if we had a problem on this board, what we would see would be the power to suddenly drop almost to that point, which we're not seeing that. And I'm simulating that with the carrier control on this radio. This radio is not actually causing that problem. So that's what we're looking for. We're not looking for a 4 or 5 watt change like we're seeing there, because we're going to see that. But we're looking for big changes in power with the power out of the ALC range. You can see when I turn the carrier control maximum clockwise that when I push and pull on the board, it doesn't change at all, because we've got sufficient drive to keep it in the ALC region. Just my hand capacity sometimes when it's out of the ALC region can cause a slight change. I saw a slight fluctuation there, but this is indicating that our problem is really not on this board. Now, most of the time I found that when we've got this kind of an intermittent power problem or low problem all the time, about 10% of the time the problem will be on the IF board. Let's take a look at that and talk a little bit more in detail about it. We're now looking at the top of the IF board again, and let's assume that we've been able to push and pull on this board and we've seen a drastic power drop, let's say from 100 watts to 10 watts, or it was only working at a 10 watt level and it suddenly jumps up to 100, then that indicates a problem in this area. Also, one thing that we can do is we can put an antenna in the rear of the unit, and we can push and pull on this board. And most of the time, if this is causing a transmit problem, it'll also be causing an intermittent receiver problem, where we can hear the receiver sensitivity jump up and down as we push and pull on this board. So that is also a confirmation that there's an intermittent connection on this PC board. So if we found out that that is the problem, what do we do about it? Well, what you have to do is try to isolate it to a particular area of the board. And the best way to do that is just to take these connectors and pull them in and out one at a time while either transmitting or listening to the receiver sensitivity if we've determined that that is dropping also. Now, it won't hurt anything to do this with power on it at all. All you're doing is making and breaking a connection, and it won't do any damage. Just make sure that we put the connector back in the right slot and that we don't touch any of the other components with it. They're all insulated wires, so it's pretty difficult to short anything out. And don't use any kind of a metal tool to push and pull on this board. If you're going to do that, use some type of a plastic tool, either the end of a pin or an alignment tool. So normally what it's going to be is one of these connectors is not going to be seated properly or oxidized. Sometimes you can also have an area of the board that's got a bad cold solder joint, and sometimes that can be very, very difficult to find. If you've determined that you can't locate it to a particular connector, what you have to do is remove the IF board from the radio, and that is easily done. There's a series of screws around the edge of the board, and the board will just lift up. You have to take a screw loose here and one in this location here. And this assembly that the IF unit is seated on will come up, and then there's a screw location right here and right here. And then if we've removed the screws around the edge of the board, the whole IF unit will lift up. We've gone ahead and removed the screws from the IF board, and you can see how easily this will just lift out. And while you're removing those screws and lifting this out, it's a good idea to have the radio turned off so that if you drag anything across any of the components, you won't do any damage. And then you can go ahead and reapply power. And as long as the underside of this board is not touching anything here or on the front panel, you won't have any problem with shorting anything out. And then what you can do, if you haven't been able to locate it to a particular connector here, you can turn the unit on and either look at the watt meter or the IC meter on the front, or if you've determined that the receiver sensitivity is also dropping, which it usually will in association with the power drop, you can flex this board back and forth and try to find the area of the board that's causing the problem. And you can see this is a densely packed board, so there's a lot of connections on there. And sometimes it's not that easy to find it, but if you keep flexing it and be persistent, you can generally find an area of the board that's causing a problem. And when you do, you can just take your pencil type soldering iron and resolder in that area of the board that was causing the problem, and that will generally repair it. Now, as I said a few moments ago, generally, turn this unit off. Generally, when you're having this intermittent transmit power problem, it will not be on this board, but it can be. So if you've done this check by pushing and pulling and you found that it didn't do anything, as we have done with this unit, the next area to proceed to is the power amplifier, and this will be where 80 to 90% of the intermittent power problems are coming from a bad connection on the PA. We're going to take a look at that and talk about how to repair that problem next. We're now looking at the rear of the 430. This is the power amplifier located at this end. This is the heatsink for it, and there is a cover which is located inside of this bracket which covers the PA. We're going to be looking at how to remove this assembly so that we can do the service work to repair the problem of intermittent power or low power output. As I said, most of the time when we have this condition, the problem is going to be on the power amplifier board. So we have to get this off of the radio in order to get to the PA so we can do what we need to do to repair that problem. Now, to do that, we remove a series of screws around the rear edge of the PA. There's a screw located here, a screw located here, a screw on either side in the same location, and on the rear, just as on the top, there's a screw located here and a screw located here. These are countersunk screws, and once those are removed, this entire power amplifier assembly can be removed from the rear of the unit. Let's take a look at how to do that. Okay, we've gone ahead and removed those screws that I previously pointed out in those locations, and now you can see that this will just freely swing back. Now, there's one thing that's going to happen if this radio has never been opened up before. It's when you swing this back, you're going to maybe see something fall out, and it's going to look like this. This is a little copper strap that is not held in by a screw. What that is, it's placed right up under here like this, and it's just the tension of it, because it's bent in an L shape, just holds it in place. And all that is for is to make sure that this is grounded to the chassis of the radio. If your radio has been taken apart before, that probably, I've got it in there and can't get it out, that probably was not placed back in. So if you don't find this in the radio, don't worry about it, because it really doesn't need to be in there anyway, in my opinion. I really don't know why they put that in there, because there's screws that go through this to the case of this, so why this is a necessary added ground, I don't know. But it is in there on all 430s that have never had this PA removed before. And if someone bothered to put it back in, it'll be in there even if it has been removed. So if you see something fall out or hear something rattling around inside, that's what that will be. And if you want to put that back in there when you put it back together, just push it up under there like that. Make sure it's seated when you put it back in. Okay, so this is freely swinging now, but in order to get it to where we can get that other cover off, is one other thing that has to be done. There's a couple of tie wraps, plastic tie wraps, that are holding wires to this additional aluminum or metal. It's not aluminum, it's steel, in a couple of locations, and we can't get this out far enough to remove this cover unless we cut these tie wraps. So just take a pair of diagonal cutters and make sure that you cut only the tie wrap and not the wires. If you get up real close to that metal, you won't get a wire in there. You just snip those tie wraps real carefully. Then you can take a pair of needle nose pliers and just go ahead and pull it on out, and then throw them away. You don't need to put those back in there when you reassemble the unit. They're only in there when they do the manufacturing process to keep the wires out of the way. You can put it back together without those pinching if you're careful. Now you can see we can swing this on back, and what we're going to be doing is removing this cover. We'll take a look at how to do that in detail and where the screw locations are. Okay, we've repositioned the radio so we can see it a little bit better, and this is the PA unit swung back. We want to remove this coax. This is going from the antenna connector to the low-pass filter. This is the low-pass filter. These are, if you can see these little black squares, these are the relays that we cleaned earlier with our resistor by passing a current through them to clean the oxidation, and this is the low-pass filter board. And this coax runs from the antenna connector to the board, and it's a little bit difficult to see, but right here you can see there's a little coax and it just pushes in, and we need to remove that in order to pull that unit back a little further. It's holding it, so we just take that little coax out. And there's only one coax connector right here, so it's easy to see where it's going to go back in. So when we take that out, it allows this to swing even further back. To remove this cover, we need to remove 4 screws, 2 on each side. If you look carefully, right here, if I can position it where the lighting is good, you can see there's a screw. Now let's reposition it so we can see that just a little bit better. Okay, I think we can see this a little bit better now. There's a screw here which we need to remove, and one just beneath it, and we have the same thing on the other side. Here. Okay, this is the side near the power connector. Let's see what we're doing here. Okay. It's good idea to use a magnetized screwdriver if possible, because it helps hold these screws. Now, there's a ground lug you can see right here, this black wire, which is located just underneath the screw. So when we put this back together, we want to make sure we put our ground lug back in. That is the actual ground for the power supply to the PA. If I can get that screw out of there. That screw is sometimes a little bit difficult to get out because of that ground strap. There you go. There we are. Now, this will pull up quite easily. As you can see, it's now removed. And what we're looking at now is the power amplifier. Now, the problem that we have is causing the intermittent power or low power is on this board. We're now looking at a close-up view of the power amplifier board after we've removed the cover. And this is our RF drive input cable. These are our 2 driver transistors that power the 2 finals, which are located here. These are 2 SC2290s that deliver the power through this toroidal matching transformer to the power output cable, which is located right here, which is soldered to the board. Now, this intermittent power or low power is caused by bad PC board trace connections on this PA, and it's usually between the drivers and the finals. There's another toroidal matching device right here. You can see it with this capacitor on top and the wires coming down and soldered to the PC board. And what we have usually is that the drivers are delivering power, but they're not getting to the finals. Part of it is, but most of it is not, and you will find that this resistor here usually gets pretty warm when this is happening. Now, to fix this problem, what we're going to do is resolder the connections on this board between the drivers and the finals underneath this PC board. We can't do it from the top because we can't get to the connections. So we have to remove the power amplifier from the heatsink, and that is done by removing the screws holding the board in place, and also the screws holding the transistors to the heatsink. in these locations. Now, some of these screws have insulating washers on them, and some of them don't. And most of them are the same size, so it's easy, if you're not careful, to get them mixed up. So what I do is I take a piece of paper and make a template the same size as this board, and I place the screws in approximately the same location that they're on when they're on the PA, so that when I reassemble it, all I have to do is look and see what location it is on the template and say, okay, well, this screw goes here. I'll show you exactly how I do that in just a second. Okay, to make your template, it's a very simple matter just to take the top cover that we removed previously and lay it on a white sheet of paper and take a marking pen and just go along the edges like I've done here. And then we've got an area which is virtually the same size as the PA PC board. And when we remove the screws from the power amplifier, we can just lay them in the same locations as they appear on the board, and when we get ready to put them back, it's easy to see where they go. That's a quick and simple way not to get the screws mixed up. Now we're going to be removing the screws and placing them on the template. The first ones to remove are the ones holding around the edge of the board. There's 4 of these. And those are just basically the same type of screws that are used in other parts of the radio. Sheet metal screws. You don't have to remove any of the wiring or plugs on this to do this. This can all be done by just removing the screws and lifting the board up in place and doing the soldering. Alright, the next that I'm going to remove, and it doesn't really have to be done in this order, but this is just the way I'm doing it. You can remove the screws in any order you like. There's the screws holding the power amplifier final transistors, the 2 SC2290s, in place. And if there's something in the way, like a component or something, you can just push it aside to gain access to the screw. One other thing I might mention, these screws, when they come out, are going to have heatsink compound on them, and it's kind of gooey and messy. If you get on your hands, just wipe it off. When you pull this unit or this PC board away from the heatsink, you're going to find that all of these transistors have heatsink compound on them. So you want to be careful. Don't remove that, because that needs to be there to provide temperature conduction from the devices into the heatsink, and that's what that compound, white compound, is for. So be careful you don't wipe any of that off, because that needs to be there. If you have some fresh, which can easily be purchased at Radio Shack, heatsink compound, you can put some fresh on there when you put it back on. But generally the amount that's remaining on the surface of the heatsink and the transistors is sufficient. Okay, we've gone ahead and removed these 2 screws on each side of the power amplifier transistors. Remove this one from one of the driver transistors, and the other one. You can see that goo there is holding that screw in place. Sometimes if it doesn't want to come out, just take either your fingers or a needle nose pair of pliers and pull it loose. Now this particular one, which is a biasing transistor, has got a small insulating collar on it, which I just dropped. You want to place those. Those are the ones we want to make sure we place on the template properly, so we know we put those back in the right place, because if we don't, if we put a screw in there that does not have one of the insulating collars, we'll short it out to ground and we'll have big problems. This one also has a small insulating collar on it. As I believe so does this one. Yes. And I believe that that is all of the screws. Let's see if I've missed anything here. Now there's one remaining that I say I missed, and that is on the thermistor. Let me show you that. Yep, well, we did miss one of the screws here. There's one more up at the top, which is holding the PC board down to the heatsink. Okay. This one is holding the thermistor, which is the heat sensing device for the fan circuitry on the PA. The screw right here, you can see the board is now loose, but if we don't take this out, what happens is when we pull the board up, we'll pull this little thermistor loose and break it loose. We don't want to do that because we would have to glue it back on to its little holder. So we take this screw out, place it just off our edge of the template so we'll know it goes on the PC board, or rather on the heatsink. And now this board will lift up. Okay. Now you can see here that we've got some of these have mica insulators, and we want to make sure we leave those in place, either on the heatsink or on the PC board, because those have to be in there for insulating the transistors. Now, there's really only, let's see, there's only two that have those, and that's here in this location and in this location, which you're not seeing because my camera's not in a proper. Okay, now this one stuck to the heatsink itself, and the other one stuck to the device. So if you want to, you can just put them both back down on the heatsink, just put it in the proper location, and don't get it mixed up with any of the rest of them. Now that the board is loose, what we're going to do in order to fix this problem, and I will assure you that in most cases this will fix the problem, we're going to resolder in this area here. And in fact, since we've got the board loose, we're just going to just about resolder everything here so we make sure we get it all. And we'll take a close-up of this board and see exactly how we're going to do that next. We're now looking at a close-up of the full side of the PC board, and this is the two, or these are the two driver transistors. These are the two final transistors, and this is the area of the board that we're going to be resoldering in to clear the low power intermittent power problem. So the way that is done is simply to take your soldering iron and some fresh solder and just heat the connections in this area and apply a little bit of fresh to it so we can get it to flow good. If you don't apply some fresh solder, what happens is there's just not enough rosin in the solder there, because it's been cleaned off with a chemical during the manufacturing process, to get the solder to flow well. So that's why we apply a little fresh solder to get it to flow well. I can't tell you exactly why this area of the board is prone to have these cold solder joints. It has something to do with what happened when the thing was manufactured, that it didn't get soldered well, or or some other reason why. But it is prone to have this problem, and it's always right in this area here. So this is the procedure, is just to resolder everything in this area, and most of the time it's going to solve that intermittent low power problem. There's no problem with the components normally on this PA. It's always these poor cold solder joints. And if you look at this with a magnifying glass before you start this, you normally can't see anything wrong. It'll look fine, but the problem we're solving is not visible to the eye, even when using a magnifying device. And when you get through doing the soldering work, it's not a bad idea to check your work with a magnifying glass to make sure that you haven't bridged any connections. And this is an area where you really want to get it good. It's where the base of these final transistors feeds through to the foil side of the board. I think that may be one of the problem areas, and where the wires from the toroidal transformer come through, which is in this area here. Just do all this entire area real well, and it won't hurt if you just go ahead and do the entire board this way, since you got it out. Just all the connections on this board. It doesn't take that much time. You think there's a lot of them, but to do each one of these, you can about 20 to 30 minutes to do all of them, and that's for sure going to take care of the problem. Okay, after you've resoldered all the connections on the foil side of this PC board, especially in this area around the driver and final transistors, we can reassemble the PC board to the heatsink. Of course, we want to make sure that we've got all our mica insulators in place, and there are two of them, and one goes here and one goes here, and then we put the board back in place and attach the screws. And you can see here we've got our template that we've used, and we've got our two mica insulators setting in place where they go between the devices and the heatsink and the screws. So you can see how easy that is just to see where they go and put them right back in place. So before you put the board back down, of course, you've got to put your two mica insulators in place. Very important that these be in here, because if they're not, you turn this on, you're going to have a short to ground in the PA, and we certainly don't want that. Now we can put this back in place just as it came out, and we're ready to reattach all the screws that we took out using our template to see where they go. One thing that I failed to mention, there is, rather than two of these, there's actually three of these mica insulators. There's one which is attached right here, and that goes on this particular heatsink area right here. So there's 1, 2, 3 mica insulators. I missed this because it was still attached to the device, and it's very, very easy to overlook that. So that's why I want to caution you again to be careful about that. Anywhere that you take off a screw that has one of those nylon insulating collars going through the top of the device down into the heatsink, you can be certain that there will be a mica insulator underneath. All right, once we've replaced the PC board back onto the heatsink, and we make sure we've got all our screws back in place, it's time to reinstall the metal cover that we initially took off. Now the way this goes back on, you can see here that there are two holes on this side. This side doesn't have those. The reason for those is there are two adjustment potentiometers located here and here, And those holes are so those can be accessed without having to remove this cover. That is for the bias on the finals and the driver transistors. When we are replacing this cover, we want to make sure that we don't pinch any wires, and there are certain holes or slits inside or in the edges and on around the bottoms of this where certain wires go through that are exiting the board, and we will make sure that those are going in the proper place and we don't pinch any wires underneath the lips. So there's a wire here which I had removed previously to access this board. Goes in this slit here. Also, this is the power feed that also goes in this particular slit. Sometimes this can be the most difficult part of putting this back together, is getting this cover back on. There's a coax on this side which goes in through here. There's also some wires which come from a plug that also goes in that slit. And there's also a coax which exits the bottom, which there's a slit for that too. And these are two wires which go from the thermistor. There's also a gap slit there for those. So when you've got all the wires in place, it will go down without any resistance. You can feel it seat in place. And you also want to check and make sure that you haven't pulled any of these wires loose from any of these connectors. Same thing is true over here on this side, which is the transverter connector plug. Make sure that you haven't pulled anything loose. If you have, just resolder it back on. Okay. Now, all you have to do is reinstall the screws in either side, and the cover's back in place. We want to make sure that before we reinstall this in the rear of the unit that we have put this grounding lug under this screw, and that on this side of the unit where our antenna coax goes, we replace that in the proper place where we took it out earlier, which is this little connector right here, and that's where that goes. And once we do that, we can reinstall this and replace the screws, and it's reattached. All right, we've gone ahead and reinstalled all of our screws in the area around the heatsink. It's firmly attached. We also want to be careful that when we do this, we don't pinch any wires in here, because on the underneath side of the unit, you can see there are a lot of wires here which can get up in here and get pinched. So we want to make sure they're all pushed back in here before we tighten this down. When we've done that and we're sure that it's properly seated, we don't have any wires pinched, we want to make sure that the radio works. So what we're going to do is going to make sure it's turned off. We're going to reinstall 12-volt power connector. And just a word about the power we're using here. This is just a 12-volt power supply. You can use your power cord that comes with the 430 attached to any 12-volt power supply capable of powering your radio 20 amps or more, or you can use the Kenwood matching power supply. Either one will be fine. And we're going to install a dummy load into the unit. What we're going to do is we're going to turn it on and make sure that the radio comes up. And I'm going to install an external speaker in the external speaker jack so that we can hear it. So we'll make sure we've got volume. We want to make sure we haven't done anything which will cause the radio not to operate properly. And you can check the receiver even on a dummy load just by sticking the center pin in the coax. You can hear the noise. So it's obvious the receiver's working. Now we want to make sure that it's going to transmit. So we'll go into the CW mode and we'll turn the carrier control fully clockwise. It really doesn't matter where we set the mic gain. And we'll go to CW. You can do this on any band, it really doesn't matter. You can see we are transmitting. We're in the IC position. Make sure we got yes. We're driving into the ALC region. So we're making power. Let's see, that should be full power. That should be roughly 100 watts on the watt meter. Many people think that if the lithium battery is bad, it will cause the radio to perhaps lose its digital readout or a series of decimal points. The lithium battery won't cause that. That is indicating a PLL unlock condition, and that is not caused by the lithium battery being defective. That is caused by usually a problem on the control unit or the PLL unit, which is pretty rare in the 430 to have those problems. Other things that people might associate with the lithium battery but which are not true are the inability to change modes or a whole series of funny numbers here which don't really indicate a legitimate frequency. The radio won't transmit or the radio will not receive properly. All those symptoms are not symptoms of a bad lithium battery. If the lithium battery is low or is totally defective, the only thing that will happen on the radio is that when we turn it off and turn it back on, it will not come back to the frequency on which it was left. It will always reset to 14 megahertz, just as if we had reset the CPU. The reset of the CPU is done by holding in the A equals B switch and turning the unit on. It'll reset to 14. That will happen every time we turn the radio off and turn it back on if the lithium battery is bad. Also, if the lithium battery is defective, anything that we had in our memory positions, it won't retain them. If we turn the radio off, leave it off for a period of time, 5 minutes or greater, and if the lithium battery is bad, we turn it back on, our memory positions will all be blank. That is really the only symptom that we'll have if we've got a bad lithium battery. Now, the lithium batteries are supposed to last between 5 and 10 years. And the 430 is getting to the age now where we might consider replacing it. In actual operation, I believe the lithium batteries will probably last much longer than it says in the manual. But if we're losing our memories or we always reset to 14, we want to check that lithium battery. Or if we think the radio is just old enough now and we want to replace it, that's certainly all right too. So how do we go about doing that? Well, the lithium battery is located on the control unit. We'll take a look how to access that next. All right, we're now looking at the top of the 430S again with the covers still removed. And this is the IF unit that we were working on before, where we were pushing and pulling, trying to determine if we had any bad connections. And to get to the control unit, we take these two screws out here, and this will just swing forward. Now this is the control unit, CPU, and our lithium battery is located in this location right here. This is about the size of a quarter, and that is the lithium battery. Let's take a closer look at that. We're now taking a closer look at the area of the lithium battery, and here it is, and you can see real close, if you look real closely, that's the negative lead, and that is the positive lead. Now if we want to check this to see what the voltage is reading, it's supposed to be 3.2 volts roughly, and we can do that by taking an analog voltmeter and placing our probes across two terminal posts. If you look real closely, or the two sides of the battery, if you look real closely, you can see there is a terminal post here, and the lead of the battery is soldered to that, the same on this side. So what we do is just put a voltmeter across that and measure the voltage. It should be roughly 3.2 volts. Okay, we're measuring across our battery, and we're reading approximately, well, about 3.6 on this meter. This 4 right here is 4 volts on the scale that I'm on, so we can see that the battery's okay. Alright, let's assume that that the battery wasn't good, or that it was good and you just want to replace it because you happen to be doing some other work on the radio and it's been in there for more than 5 years, the battery, and you decide you just want to replace it to save having to do it later. And that's perfectly alright to do that. So what we do is we're going to remove this, and this is soldered on these posts, and it's a little bit hard to get that out of there, because what can happen is when we get this hot enough to remove the battery lead, we get it so hot that we sometimes can pull the post right out of the PC board. So the best way to do this is just to take a pair of diagonal cutters and cut the lead up as close to the battery as possible on either side, and then we take our new lithium battery, which looks just like this, and we'll put it in there. And the lithium battery is marked. You can see, I hope you can see, that that is the positive end. Alright, so this post is the positive side, so you'll place it in there just like that, and just wrap it around the post just a half a turn. Same true with the negative lead, and then solder it in and clip the excess tab off, and you've replaced the battery. And there really isn't anything else to do except put the new one in. Now the part number on the new one, and the battery type is a CR2032. Now you can buy those. I believe you can get those type at Radio Shack, I believe. This particular one that came from Kenwood is a Sanyo. Mallory also makes that model. If you want to order the battery directly from Kenwood, which is what I suggest, because you can sometimes get the CR2032. It'll be the same size, but it will not have the proper lead length on it, and it's sometimes difficult to solder in. So the Kenwood part number is W as in whiskey 09-0323-05. And once you've got the battery back in, you can go ahead and button it back up by placing that top cover and putting the screws back in, and you're through with that one. Let's next talk about how we're going to go about changing the pilot lamp behind the S-meter in the 430. This is the only pilot lamp that we have in the 430. The S-meter is located directly behind the lamp, or behind the meter, right behind this area here. We'll take a little bit closer look at that area. Alright, this is the area directly behind the S-meter, and you can see the pilot lamp right here. It's not difficult to get out at all. You just take a pair of needle nose pliers or your fingers and pull it out like this. Now the problem here is that the lead lengths are very, very short. We don't have a lot to play with. A little bit more came out there. Sometimes you can't get quite that much out, but there's enough here to change this, or on any of them really. But sometimes you want to cut the wire up near the bulb as close as possible to it. The reason I'm doing this way, rather than trying to find out where it goes in here and resolder it, that is hard to do. We have to remove the front panel of the radio in order to do that, and that's not necessary. It's easier just to take it and snip it like so up near the bulb. And take our new bulb, and I'll give you the part number on that bulb in just a second, and we'll take it and we'll just trim these wires back and solder them together. And what we do in the shop is we just use some heat shrink tubing and put it over each wire. and then take a heat gun after we've soldered and shrink it down. That will insulate it. If you don't have heat shrink tubing, you can just put some electrical tape around each wire after you've spliced them together. Okay, I've gone ahead and trimmed these wires back and twisted them together, and I'm just going to apply a little bit of solder to each one. Just like that. And if there's any excess link sticking out from either side, I'll take a pair of diagonal cutters, cut it off so that it feels smooth, and then I push my heat shrink tubing. Now there's an area that I didn't get cut off very well. Just push the heat shrink tubing over it like that. Then I take a heat gun and just heat this up. And like I said, if you don't have the heat shrink tubing, just put some electrical tape around each one. That'll be fine. Once we've got our tubing or tape installed, we can go ahead and just push this excess wire back in here. There's plenty of room for it. And then we can push our bulb back in its slot. You can see right here that here is the slot for the bulb, and the bulb has a little collar around it that fits into, or that the collar fits into, I should say. And after that's done, before we go ahead and put our covers back on, we want to make sure at least that we did install a good bulb. Sometimes you can get a new one and it'll be bad. It's pretty rare, but it can happen. So before we have to take the cover back off again, we'll just put our power connector in and turn it on and make sure it comes on. That looks like it's working to me. Okay. And that's all there is to installing the S-meter pilot lamp. Alright, the part number for the pilot lamp, the Kenwood part number, B30-0817-15. B as in Baker, 30-0817-15. That's the Kenwood part number on that 12-volt pilot lamp. Now that particular bulb is used in several of the Kenwood radios. It's used in the 940, the 440, the 140, and the 430. So if you have more than one Kenwood radio, you can order that and use that as a replacement for any of the 12-volt radios that use a pilot lamp in their S-meter. We're next going to be taking a look at how to calibrate our frequency readout so that when we say that we're on, let's get within the ham band, say 14319.00, we can be sure that that's where we are. And the way we do that is to adjust the reference oscillator on the PLL circuit, which is located on the control board, so that it is exactly on frequency. And we do that by reference to WWV. This is a very simple adjustment and very, very accurate. Now before we do that, the 430S comes from the factory without the last digit showing, the last 10 hertz digit. And there's an explanation in the owner's manual as how to get that to come on. And this is a nice feature to have, especially when we're sure that our reference oscillator is on frequency. So this is very easy to get that to light up. We'll take a look at that. That's on the control unit. All right, we're looking at the front of the radio here. This is the top, the IF board. We're going to swing our top panel open just like we did before. And this is the area where we had looked to see about the lithium battery before. There's the lithium battery. And to access that last 10 hertz digit, there's a jumper that we cut here. And it's already been cut on this unit. But that really doesn't matter because all I'm going to do is show you its location. If it hasn't been cut on yours, you can see where to do it. Now, it is right next to resistor R202, and there it is at that location. That's difficult to see this far away from it exactly which jumper I'm talking about, we'll get a real tight close-up of this area right here so you can see exactly where it is. Alright, we're taking a little bit closer look, and you can see this is R202. This pin is directly on the top. That's R202 right here, and you can see it written on the board, R202. And the jumper is just to this side of it. You can see it right here. I'm moving it with my pen. You can see it's already been cut. And that's what we do. We cut that jumper. You see one side of it there. And that allows that 10 Hertz digit to be displayed. Alright. So that may have already been done on your unit. You may have already done it because it is in the owner's manual. If you hadn't, that's very simple and easy to do. Now we do that, we button the top cover back on, and then we'll take a look at the front and see how to adjust the reference oscillator. We now want to take a look at how to adjust the reference oscillator, and what we're going to do, we've put a power cord in the back. I've connected an external speaker and an antenna to the unit. And we're going to tune in WWV, time standard, which transmits a tone for 30 seconds of every minute. And we tune to 15. Now, if we don't have propagation at 15, we can try 10 or even 5 megahertz. 15 is preferable because the higher the frequency that we do this adjustment on, the more accurate it happens to be. So what we do is tune to 15, and we switch between upper and lower sideband while that tone is on. There we are. Let me turn it up where we can hear it. Now I'm switching between upper and lower sideband. Now you can hear that tone shift frequency. Now when our reference oscillator is exactly on frequency, there will not be a frequency shift. It will be the same tone. Now we have to make sure that we're tuned to exactly 15,000,000, all zeros. Or if we're using 10 megahertz, 10,000,000. Because if we don't and we adjust to some other frequency, it's not going to be accurate. So if it's adjusted properly, there will not be a shift in the tone between upper and lower sideband. So this is off a little bit, as you can see. And then the tone is not on. We have to wait till it comes back on. Right, but let's go ahead and take a look at where the adjustment point happens to be. And that's on the side of the unit. We've got both top and bottom covers removed. This trimmer capacitor located right here. That's the one we're going to be adjusting to adjust the reference oscillator. The crystal is located just behind it here. You can't see it with this cover down, but that is the adjustment point for the reference oscillator crystal. Alright, let's turn it back around. Put that under there to prop it up a little bit so you can see it better. Turn the volume back up. Now I'm going to put an alignment tool, which I'm using, which is a blade. It's plastic with just a metal blade insert. And I'm going to try to adjust this. Of course, we have to wait until we have the tone. Make sure we're exactly on frequency. Now you can see that's very, very close. I don't know that I can get any closer than that. Let me try. There we are. Now you can see now that there's no difference between upper and lower sideband when we're set to exactly 15 megahertz. And that was done simply by switching between the two and adjusting that trimmer capacitor for the same tone. Now we can be certain that we are exactly on 15 megahertz. Or any other frequency that we tune to, it will be totally accurate. We're next going to take a look at how to make the 430S transmit out of the ham bands, for instance, on the Warwick bands or on the Mars transmit frequencies. As the radio comes, it will not transmit on anything but the ham bands, and even I think at the time that some of the 430s were produced, we didn't have authorization to go on the Warwick band, so it will not transmit there. At least on some of them it will not. So how do we do that? Well, it's very, very simple. First, we want to make sure we've removed the power from the radio. Turn the radio upside down after having removed both top and bottom covers. And connector number 10, there are two wires that we're going to snip there. Connector number 10 is located right here. We're going to pull in and do a real close-up shot of this so you can see it better, but this is the location of connector number 10. As the radio is facing you, it is on the left side, about in the middle of the radio. And the number 10 is written on the board near the connector, but it's very small and somewhat difficult to see. We're now looking at a closer view of the area of connector number 10. This is the connector. This is the front of the radio, and we're looking back along the RF board. And this is the connector. Now there are three wires in this connector, and you pull it loose from the board. Alright. There are three wires here. There's a green wire, and in this case there's a purple, white, and a gray. Now these colors will vary, at least these two. There'll always be a green wire in the plug, but the color of the other two may be different depending upon the serial number of the radio. But leave the green wire. What we want to do is snip these two wires and leave the green wire intact. You snip these two wires and just put some either heat shrink tubing over it and heat it up, or a piece of tape so that it doesn't they can't touch anywhere else in the radio and short anything out. And then put the connector back in place with everything, these two wires, cut and leaving the green wire in place. And that will do the modification to allow the radio to transmit anywhere within the HF spectrum. There's one other thing you want to do after you cut these two wires. After those two wires have been cut, we want to reset the CPU. First thing we do is insert the power cable in the rear, turn the unit on, hold in the A equals B switch while we turn it on. That's this switch located here. Release it. It resets to 14 megahertz. The reason we're resetting this is that the CPU may not recognize what we did with our modification, so we want to make sure we didn't put any kind of a glitch or anything into the programming of the CPU so that everything works out okay when we try to transmit. Now it will of course transmit at 14 megahertz. It would have done that anyway without the modification, but let's just check it and make sure everything is still working okay. You can see I've got my meter in the IC position, and we're reading about 15 amps, so we're transmitting at full power into a dummy load. But let's step it up. Okay, now that frequency would not have normally transmitted, or the radio would have not normally transmitted on that frequency, but now it will because we've performed this modification. So now we can transmit on any of the Warwick bands or any of the Mars frequencies, or for that matter any HF frequency that we are tuned to, we can receive on and transmit on as well. That's been a look at the Kenwood TS-430S. I hope it's been useful as well as informative. If you would like more information on this video or any others in our series, please refer to the address and phone number that will appear on your screen momentarily.